The James Webb Space Telescope, also known as Webb or JWST, is a scientific trailblazer that has revealed amazing details about stars, planets, galaxies, and other fascinating cosmic phenomena. In addition to setting new standards for scientific excitement, Webb is hailed as the venerable Hubble Space Telescope's replacement. Individuals from all around the world are exchanging photos or using raw data to create fresh insights. 1 year has passed since the formidable James Webb Space Telescope unveiled its first ever historic image of the universe, shocking astronomers all across the world with its extraordinary detail. But its most recent finding is a horrifying picture of the universe that we have never seen before. What has been found thus far by the James Webb Space Telescope is posing more questions than it answers for scientists. Join us as we explore how the James Webb Space Telescope captures the most terrifying image ever seen in history. The successor to the Hubble telescope unveiled new information about star formation, galaxy mergers, and the early cosmos just 1 month after the initial photos were released. The pictures were breathtaking, revealing the universe in breathtaking detail. Since then, the number of discoveries has skyrocketed, providing scientists with an enormous data treasure mine. James Webb Space Telescope observations of cosmic tarantulas, record-breaking space smoke, stars on the verge of supernova explosions, and other incredible celestial objects have been documented. This satellite observatory's cutting-edge technology allows us to peer farther into space than before, revealing previously unknown details about the cosmos. A new era in astronomy has dawned, thanks to the photos, which can be so detailed. As a way to commemorate the first year of the James Webb Space Telescope's operation, NASA released a picture that shows a tiny star-forming area in the Rho-Ophiuchi cloud complex. The picture shows jets erupting from newborn stars as cosmic dust. Clouds of various colors collide. Molecular hydrogen makes up the red dust, and the presence of a circumstellar disk casts a shadow on a few stars, suggesting the possibility of planet formation in the distant past. The picture may show cosmic mayhem, but according to NASA, this stellar nursery is tiny and peaceful compared to others. Additionally, many of the young stars in this area are about the size of our Sun or even smaller, making it the nearest star-forming region to Earth. This picture was captured by the main camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic images in 2 distinct infrared spectrums all at once. Furthermore, the Space Telescope has improved our knowledge of exoplanets or worlds that orbit stars other than our Sun. James Webb is particularly good at looking at large, faraway galaxies. The satellite observatory discovered its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years distant and has a diameter comparable to Earth's. James Webb, according to NASA, is the sole operational telescope capable of classifying the atmosphere of Earth-sized exoplanets. According to the scientists in charge of the study team that made the discovery, the findings demonstrated how precise the telescope was, and rocky exoplanets are now a new frontier for astronomers to explore. After that, the James Webb Telescope found proof of long-gone galaxies that, from a theoretical standpoint, shouldn't have existed. Ivo Labbé of Swinburne University and his worldwide astronomical team have found 6 enormous old galaxies, called universe breakers, and they have the potential to completely change the way we think about space. These massive galaxies may have come into existence between 500 and 700 million years after the Big Bang, according to the researchers' results earlier this year. The telescope's infrared sensors detected them. Through the use of these instruments, we are able to glimpse back in time around 13.5 billion years when stars and galaxies were much older. The enormous vastness of the cosmos breakers has left scientists bewildered. Galaxies in the early universe should have been 10 to 100 times smaller than that. Their calculations indicate that these 6 objects may be billions of times heavier than our Sun. The sum of all the stars in one galaxy might be 100 billion times heavier than our Sun. Does the thought of trying to understand something so massive give you the willies? Even though the majority of galaxies during this period are relatively tiny and are just expanding ever so slightly, some monsters reach adulthood far more quickly than others. It is unclear what would cause this or how it would function. Penn State University astronomy and astrophysics assistant professor and study co-author Joel Ledger expressed his astonishment at the discovery of a new category of objects formed at the Big Bang. The discovery that the development of huge galaxies started at the very beginning of the universe's history challenges many of our previously held beliefs about the state of science. It seems our discovery is so out of the ordinary that it poses challenges to the scientific community. It throws into doubt the entire scenario of how galaxies formed in the early universe. Way more massive than anyone expected describes the things. All galaxies in the range are considered babies since they are still in the process of formation. However, galaxies that are as old as our own have been found in the early cosmos, which was previously thought to be its beginning. Spectrometry, which separates light into its component wavelengths to enable more accurate distance measurements, is still required to validate the results, which have scientists scratching their heads. There are only a handful of recently found objects for which distance and mass have been verified. If the data is accurate, galaxy creation had to have been considerably more efficient and rapid than what is now thought. The fact that spectra corroborated our standard operating systems-based inferences from the visuals is promising. For years, scientists have sought to decipher cosmic history. Nevertheless, a single piece of machinery may hold the key. Observations of space and time have long piqued the curiosity of scientists, so it is not surprising that conflicting facts presented by telescopes might lead to a lack of clarity. At this point, cosmologist Dr. Katie Mack has chosen to offer her insights into the matter. In order to explain how this could be occurring, she brought out the fact that the JWST has been providing evidence of galaxies that seem to have originated or matured much earlier than what scientists had anticipated from their models. Do not worry. As Mack pointed out, the telescope is capturing images of galaxies over 13 billion light-years away, and they are somewhat blurry. It seems like there hasn't even been enough time since the Big Bang for these big galaxies to have formed according to the dates that cosmologists have been receiving from the telescope. Many in the field were concerned that this cast doubt on various theories, including dark matter and the Big Bang. But we should go further into the evidence to find out for sure. The telescope captures breathtaking views of close nebulae, but fuzzy little dots when it comes to faraway galaxies. The reason is that different colors are affected by different parts of the light spectrum. The Webb telescope can detect light from a source in two different ways. It may utilize a spectrum by spreading out the light with a spectrograph, which works a bit like a prism, and examining the brightness of each color. Or it can use filters that block all but a select range of colors. They can then calculate the redshift of the galaxy by comparing this data with spectra predicted for galaxies with the same characteristics. What this redshift informs us is the exact instant in cosmic history that we are viewing it. It turns out that many galaxies have an excess of stars or stars that were too young when they would have lived according to comparisons of model spectra. There are a number of possible explanations for this. The photometric readings might have been off because of problems with the telescope's calibration. Alternatively, they may have been observing a cluster of galaxies that is